We're at the cable show, and we're at the booth of a company called Qwilt. Qwilt's fairly new to the industry and has some pretty interesting technology to offer when it comes to bandwidth control. And we have the opportunity to speak with Mark Fisher, who is the Vice President of Marketing and Business Development for Qwilt. Thanks a lot for taking the time to speak with us. Let's get started with just telling us who you are. How long have you been in operation, and what brought you into operation?
Sure. Qwilt has been around for about 3 years, founded in 2010. Classic venture-funded startups in Silicon Valley. A few years ago, the founders and a couple of VCs got together and realized that we would soon be facing a storm, if you will, of video traffic, over-the-top video traffic from people like Netflix and Hulu and all the rest. And they realized at the same time, these were ex-Cisco, ex-Juniper folks, high-performance networking types, that no one had created a solution to address the architecture that's needed to address this video problem that operators face today. So they founded Qwilt and funded the company. Here we are.
Well, so what? I guess the key question is, when you started out, which wasn't that long ago.
Yep.
Did you have any idea that this much would be happening in video traffic?
Yeah, it's a great question, and what's remarkable is that every night right now, at peak hour, about a third of the internet is fully occupied by Netflix streaming movies here in the US. And about 2/3 of the internet is all of the streaming video taken together. And no, I don't think anyone realized this would take off as fast as it did and be as significant as it did. And we've been talking to operators now for a couple of years, and we're having operators tell us they can't keep up with the growth in traffic. Operators who are seeing certain markets double in total traffic in 6 months' time. So it is surprising, I think, to everybody. How many people are in the market offering content, how the race of quality content, now people are talking about 4K streaming content, Ultra HD video streaming over the internet to your home. It's extraordinary.
So the operator obviously has a tremendous load of traffic coming in. They have virtually no control over that traffic. They have regulatory barriers to playing games with that traffic. And so they're between a rock and a hard place. It's real hard to figure out how to monetize off that.
Yeah.
And at the same time, they're risking incurring some really bad consumer experience on their broadband networks if they don't do something about it.
Yeah.
So you're addressing that question. Tell us what you're doing to address it.
Yeah, and I think you've captured the main points, because what we're sensing that operators care a lot about is having visibility. What does this traffic look like? How significantly is it growing? Some control over the optimization of it. How do they best architect a network to deal with this kind of traffic? And then how do you create a great consumer experience at the end of that? And so our solution, said simply, is to sell to the operator technology they place at the very edge of their network, deep in their network, near the neighborhood, the town, where it can autonomously and automatically detect popular videos streaming across the network into someone's home, locally store it, cache it on our device, and then the next time it's detected, it's requested by a consumer down the street, we'll actually deliver that video instead of having to send that video, the operator having to send that video all the way back across their network to that consumer. So we're taking what is today this sort of very repetitive, redundant process of many, many streams of content across the same network, and essentially offloading that video by caching it locally at the edge, deep in the operator's network. And when we do that, we can reduce the traffic by 50 or more %. Everybody wins. The network operator spends less on capacity because we've offloaded video traffic. Consumer gets a better experience because the video is being delivered from close to where they are, and the content provider gets their content to the consumer, which is at the end of the day what everybody wants to do.
So, I mean, in a generic way, this is very CDN-like content delivery network-like, and it represents the private CDN side of what a lot of people are talking about. Certainly other CDN suppliers are now moving in that space with their ideas, and some that aren't CDN suppliers, like providers of edge distribution system for VOD, for example, are now introducing these kinds of capabilities. So what are you doing that you would say sets you apart from some of these solutions?
Good question. So, and just to add to your point, because that's exactly right, in looking at everyone else in the ecosystem, and this is where an ecosystem is vitally important. This is a team game here, if you will, team sport. We complement the content delivery that's already in place by CDNs. The operator may have their own internal CDN where they're delivering over-the-top video, streamed video. We complement it by several dimensions of our product, which are what set us apart. We're positioned at the very edge of the network, so deep into the operator network. Most of the other solutions are data center kinds of solutions where it's racks of equipment. We have one sleek 2U box that we deploy deep into the operator's network.
So you're talking about hub level penetration?
That's right. Adjacent to the CMTS, next to the BRAS. So hundreds of these deployed throughout the operator network. We are a purely out-of-band solution, so we in no way affect the reliability or performance of the network. In the event of a failure, it fails to wire, and we never affect production traffic. So we can sit, if you will, out of band and watch and classify traffic, and then store and then deliver video in that configuration. And then from this perspective, we have 5 times the performance of the next best solution. That's typically a data center-based solution. And then finally, we're universal. So we can detect and deliver OTT video regardless of the source. So we have a very sophisticated, deep video classification engine that's a part of our solution that actually can see video traffic, determine the source and type, and determine whether it's something that we should cache. That in combination makes our solution there at the edge of the network very different.
And so one thing implicit in what you're saying that distinguishes from the normal CDNs is you're focusing on the video traffic. I gather by implication you're saying you're letting the rest of the stuff go through.
Correct.
It's the video traffic that you're caching, so you're not clogging up the cache with a lot of things that don't need to be cached.
That's exactly right, and even going maybe a step further, because we're purely out of band, none of the non-video traffic ever passes through our system. So we are looking through an optical tap at traffic, classifying only the video, and then and only then, if it's video traffic that's important and popular, do we take the step to cache and bring it to our system.
And then you mentioned that within the video you do some gradations on what that is, and how does that work, and what are some of the parameters that determine the caching or not, or just how that works as far as...
Sure.
Because again, you're not prioritizing the traffic based on whether it's the internet or the operator's traffic, right?
So to this point, because it's a universal cache, we can cache operator video traffic that may be coming through their own internal CDN, and then we can cache any traffic coming potentially from other commercial CDNs or from the content source. And we, through deep video classification, develop signatures for all of this traffic, and then once we're active in the network, the unit operates on its own, determines what's popular, and then caches it and delivers it. Just one particular example of this is the way we handle ABR traffic, which is growing.
Adaptive bitrate streaming traffic.
Thank you, yeah, which is a growing component of the streaming traffic we're seeing from many content providers. Because of our caching approach, because of the deep video caching we use to actually detect traffic, we can see ABR traffic holistically as a complete video, cache it as such, and then deliver it when requested next as a complete and contiguous video. In other caching examples, they actually see ABR as the small little chunks, the segments that they're chopped up into, and in many cases can't recognize it as one continuous video. And all this comes down to caching efficiency. They suffer when it comes to caching efficiency because they may or may not be able to connect the next requested video from the consumer down the street to the video we just cached. So these are some sort of specific examples of where we ultimately deliver a higher caching efficiency regardless of the content source, and that's the measure for the operator of the ROI that's a part of our solution.
What about the increasing use of edge intelligence to add to what's going on at the caching points with respect to getting into those fragments, sending other fragments that are, say, advertising related or special add-on features for second screen or whatever it is, actually using that ABR technology which sends out these messages to the clients with that are called manifests, where they tell the client, here's what you're choosing from, that kind of thing. How does that work in the context of what you're offering?
Well, let me answer it in two parts. First, with respect to ABR, there's really two planes of traffic. There's a control plane of traffic where things like session, authentication, rights management, and statistics are being sent. Let's use an example like Netflix. We are not inside of that plane. That's if you will, a thinner stream of data, and we do not in any way affect the business logic associated with delivering that video to the consumer. Once Netflix says, yes, that's a subscriber, yes, they've ordered this video, let's deliver, then we jump in, and when it comes to delivering the heavy, the dense content, the HD, Ultra HD video, then, and it's in ABR format, then yes, we get involved, we've cached that locally, and we can then deliver that locally. You may also be talking about where this is going. How do we take advantage of the intelligence at the edge of the network for things like potentially ad insertion and other kinds of value-added services? This is an interesting, I think, area of development that we see as potential, but we sort of see it in these two parts today. And so right now we're really focused on delivering that ABR content to consumers.
So when it comes right down to you when we started out, you're talking about people that implement this are looking at saving 50% off of their traffic volume.
Right.
Is this after they already are, in proximity to CDNs that are out there already? Is it based on adding on, or is that just raw non-CDN traffic?
No, it's taking into account the environment that the operator currently is operating within, and offloading 50% of video traffic, taking it to the very edge next to, say, the CMTS, and by doing so, reducing the capacity necessary from that CMTS back to the core, where the operator's peering with the internet, where they get transit, and where likely other caches are adjacent,
right.
A commercial cache, that maybe their own internal cache. That savings is very meaningful. That's through their regional network into the metro network, and for at least the operators we're talking to, where we have deployments active, what we're hearing is less than 12-month ROI to deploy our solution and immediately see the benefit of increased capacity in their own network, not to mention the improvement in QoE for the consumer.
Okay, well, it sounds like you have a pretty winning proposition.
Yep, it's been a lot of fun.
We'll definitely stay tuned and see how it's going.
Excellent. Thank you.
Thank
Good to talk to you.
Good to talk.
Appreciate it.